have a
que elas
project
buscam o
in
Senai para
mind
tentar
and they
auxiliar
come to
no
Senai to
desenvolvimento
help
desse
them
projeto.
in
E
developing
aí
this
o Senai
project.
Cimatec ele apresenta
So
um modelo
Senai
integrado
Cimatec has
com um
this
centro tecnológico, uma
integrated
escola
model,
técnica e um
a
campus universitário
technological center, a
e
school, and a
integrando todas essas
university.
áreas a gente
So we put
desenvolve
together all
pesquisa,
of the
desenvolvimento e
areas
inovação.
and we promote
O
research,
Senai ele conta com
development,
6
and
campos
innovation. We have
distribuídos no estado
6
da Bahia,
campi
conta com mais de
in the state
1.400
of Bahia,
colaboradores e bolsistas, já
1,400
teve mais de
employees,
200 milhões de
more than
dólares em
$200
investimento
million
ao longo de
in
todos os anos
investments
e conta
over
com
the years,
44 áreas de
with a
competência.
44
E
different
entre essas
areas.
áreas a gente pode citar a área
We have
automotiva, a área de
automotive,
materiais, na qual eu desenvolvo
materials,
minhas
where I
atividades.
work,
Temos a área de mineração, de
mining as
meio
well,
ambiente, de alimentos.
environment,
Então, todas essas
food.
áreas elas
So all of the
contribuem com o
areas they
desenvolvimento de
contribute
pesquisa na
for the
indústria.
development
E
of
também na
research
parte
in the
de
industry
qualificação
and also
profissional
in
por meio
professional training
das atividades no campo
by
universitário e na
means of
escola
the
técnica.
activities of the university campus.
Como eu
Through
falei, né, nós
our
temos 6
school,
campos.
we have
O Senai
6
Cimatec Park
campi.
fica localizado
This one
em
is
Camaçari.
located in
Lá no canto a gente
Camaçari.
consegue ver.
I don't
Acho
know
que
if you
não
can
tem aqui, não está
see.
apontando. Mas o videozinho, ele mostra o Senai
The video
Cimatec Park, que
shows
conta
the
com
park
galpões.
that
E
has,
nesses galpões
industrial
temos tanto
sheds. In the industrial
laboratórios,
sheds, we have the
naturalmente de
labs
inovação,
of the
quanto
institution.
piloto de algumas
We have
empresas
pilot
que
plants of some
atuam
companies, such as
nesses galpões, né, no
Ford,
Senai Cimatec Park,
that uses one
que
of
fica ali
our
no
industrial
município de
sheds
Camaçari.
in the
O Cimatec
municipality of
Shed fica em
Camaçari.
Salvador.
The headquarters located in
Temos também o
Salvador, the
Cimatec
capital
Mar, onde
city.
são desenvolvidos
We have
estudos a respeito
Cimatec
de
Mar, where we
navegações
study,
ou
vessels,
outros estudos
and we do other
relacionados
studies
à área
related
marítima.
to the maritime
Temos Cimatec
industry.
Sertão,
We have
que fica
Cimatec
em
Sertão
Conceição do Coité,
in
no
Conceição do
contexto da
Coité,
Bahia. E
in the
ele
countryside of
busca
Bahia,
aplicar o
and
desenvolvimento de biodiesel com
we
uso
aim at
de
developing
sisal,
biodiesel with the use of
que é
sisal.
relacionado ao sisal.
That's a
E ele
plant,
conta com
right?
um apoio
Sisal.
social,
And we have the
comunitário
social aspects with the
e
community around it,
além do desenvolvimento do biodiesel, a gente também atua
and the
em
development of
como
biodiesel.
utilizar ao máximo tudo,
We
toda
try
a
to use
cadeia
as much as
de sisal.
possible all the
E além
chain of
disso,
sisal,
inclusive as fibras de
everything that is
biodiesel. E
associated to
temos o Senai
sisal.
Cimatec Área de
And we have
Desenvolvimento
a
Sustentável
Senai
no
Cimatec
Salvador.
located in the Euro base of
Como
Salvador.
eu falei, eu atuo no laboratório de polímeros, então esses os projetos que eu vou
Well, the
apresentar
projects that I'm going to
no
introduce to
dia
you
de hoje
in
são
today's
de biodiesel.
presentation, they were developed in a polymer lab at Senai
Então, ela
Cimatec.
também busca o
The
desenvolvimento
lab
por
aims
meio
at
de
developing blends and
foco na
polymer
sustentabilidade.
composites focusing on
Então,
sustainability and
usamos
circular
rejeitos
economy.
da
So
indústria
we have been
para
using
detectar
the waste as
restos de
waste from
adubo
wood,
rural,
the rice
restos de
hull,
café, restos de
sisal,
coco
the waste
e
from
cereais
coffee, from
e
coconut
incorporar
and
isso em uma
pulp,
matriz polimérica
incorporating
que
this in a
permita
polymeric matrix and a polymeric
trazer essa
core
rentabilidade para esse
to,
produto.
bring
Então, o nosso
profitability
propósito é
to
estar
these components.
atuar junto à
So
sustentabilidade.
we aim at working with sustainability, investing in the
Falando um pouco
circular
da nossa
economy.
infraestrutura, nós
Speaking
contamos
of
com
our
equipamentos
infrastructure, we have extruders,
para
um, single worm and double worm. We have the tubular extruder to produce films, injection machines to produce
algumas empresas elas querem
tryouts and specimens.
né, fazer o teste de
Sometimes
molde
people want to
para
change their mold. We can test the mold using this, and also a profile extruder, the thermoformer, and the thermal presses as well. This is our team. We are coordinated by Professor Pisano. He's here. Should you have any question, you may talk directly to him. We have Eric, who is our lab technician, and Scarlett, Tatiana, myself, Jamil, Paula. We are the masters and the doctors working in the lab. And we have Tiago, who is our intern. Tiago is our
saindo, tá?
intern.
Aperta o 3 ali, por favor, de cima.
Okay?
Esse, pronto. Agora pode falar.
Well, speaking about R&D for the development of products for the industry, we have specialized services. We do lab tests. We have so many types of equipment like electronic microscopes, tensile machines, the fluidity meters. Everything can be done at Senai. We can also do failure analysis, and we can provide consulting services as well.
mostrando assim alguns dos
Well,
projetos
some of the projects that have been developed,
produção de cadeiras,
the production of chairs,
pellets,
profiles, and pallets that are used after the mix of their
e
composites.
também
We
atuamos
produce
nas áreas
decks.
estruturais.
We work in structural design. We have this project with a Shell to use structural adhesives for the naval industry. So that's one of the examples. As I said, we also have equipment, the scan electronic microscopy, and extruder that is used for the production of specimens as well. Speaking about the topic, some studies from the literature speaking about the challenges of developing composites with natural fibers. This paper talks about the complexity of the use of the fibers. If there is a slight change, an environmental change, for example, this can influence the property of the fiber. When we use the fiber into the composite, this can interfere in the end product. So the fibers, they're quite complex in their structure. This can result in different properties. The age of the plant, the climate conditions, the processing techniques can influence the structure and the chemical composition of the fibers. So when we use this in a composite, we need to properly choose the polymeric matrix that is going to be used. We need to be careful with the processing temperature, and this can result in different properties of the composite that is obtained. The chemical structure, it is based in cellulose for all of the fibers. It's similar for the fibers. There are different degrees of polymerizing, and the grain size can play an influence on the fibers. They can have a low wettability, degradation during the process. So we should be concerned about the processing temperature for the composites. And then the interface, poor interface. So we must use compatibility agents during the processing when this happens. And all of the factors can reduce the strength. If there is no good interaction between the filler and the matrix, we may reduce the strength of the composites. So we need to properly choose the fiber, the processing conditions, and the additives that will be used in the product. A second paper. It supplements the previous work. We discuss here the parameters that play an influence in the mechanical characteristics of fiber reinforced composites. We have to pay attention to the alignment of the fiber, because if we have a unidirectional fibers, depending on their position, we can shift the properties. We need to carefully choose the matrix to see whether it's appropriate, whether the temperature, the processing temperature is appropriate for that fiber. So we choose the fiber. We have to think about the aspect ratio, the content processing, the processing itself. We have to check the interface strength. If the fiber and the polymeric material do not interact well, the composite is not going to be of high quality. The fibers, they can vary in terms of porosity. This must be taken into account. We have to consider the manufacturing process and how to improve the dispersion of the fibers throughout the piece. Let me talk about the projects that have been developed at Senai Cimatec. The first one, it uses coconut fibers. So in this project, we incorporated 30% of fibers in a polypropylene matrix. So in this first image, we can see the material and the output of the extruder. And then the fiber was used in the polypropylene matrix, and then the pellets were obtained. The pellets were used for specimens, and they were tested. We have the microscopy and the tensile strength results. I'm not going to drill down, but when we compare the four images, we can see the voids in the first three ones and a low level of interaction between the polymer and the fibers in the three first ones. We highlight that in red. The interface is not so good between both materials, but in the last image, we used a compatibility agent. So we improved the interaction on the interface, fiber and polymer. And in the tensile tests, we can see the properties. Image D in the chart is the lighter shade curve showing increased strength, and a better deformation of the composite when we use the appropriate compatibility agent in this material. So, as key challenges for the development, we have the incorporation of the reinforcement. So when we do the processing of composite, we have issues from the feed stage because the fibers they get tangled, and that's hard in the input process in the extrusion. There might be a high humidity content, so we have to be concerned in the pre-processing. We need to properly dry the fibers. Another issue during the extrusion processing, that's the continuous processing. If there is a lump of fibers in the polymeric matrix, we cannot pull the material. So we need to be careful in the feeding process. Sometimes we have to use a crate, because we want to prevent the lumps of fibers. I mean, the process must be continuous. We need to be careful with the compatible materials, and in using the composite, sometimes we cannot obtain a very good superficial finish depending on the fiber content. So these were the key challenges. This is what we saw in our team in this project. The second project that I have for you, it's a wood-based composite. So we used poly wood. It was used to manufacture decks for vessels in partnership with the Navy in Brazil. So we have different kinds of particles of wood that were used. Look at the results. We have the pallets, and the key challenges were the grain size, because we had to properly control the grain size so that the composite attained, homogeneous properties. The color of the wood may interfere in the final product. So if you want to do this in large scale, the color can be an issue. Depending on what type of wood you use, then you have different colors, and that can be a challenge. Well, we need this to be equivalent. Also, water absorption. We need to properly dry the material before processing it. And application is for the deck, the external deck of vessels. So we have to be concerned with the UV degradation. So we use additives to protect the material against the degradation. Well, polypropylene composite using rice hull to be used in fences and decks, boards. So we had to use additives in this composite with an anti-UV light agent, and also flame retardants had to be used, because by adding the flame retardants, the civil construction industry requires that, because most of the products that use polymeric materials, they need to have, the flame retardants added. The key challenges were the processing temperature, because the rice hull is quite sensitive to temperature. So depending on the process, we may degrade the peel, the hull of the rice. That's an issue, because instead of a fiber, it becomes carbon in there or coal in there. Also another issue, superficial finish, because we're adding this fiber that can change the surface. The surface may not be smooth. So depending on the product, we need to be careful. And also the use of compatibility agents, okay? Another examples, using a PP composites and sisal fiber. So this product used the byproducts of sisal to be a filler in the polymeric matrix. So images about the sisal, the fiber itself that was used, it had to be chopped. We do not develop composites with long fibers. We usually chop the fiber to be able to add it to the polymeric matrix. Some examples of products that were obtained in Senai: house appliances, hard hats, soap holders and chairs, to develop also wall. It's desks actually that they produced for the schools in the state of Bahia. This project was done in partnership with the state government, and the challenges associated to this kind of development. We can see the high content of fiber being added. So the higher the percentage of fiber being added, the more difficult the process is, and there might be issues in the input process. It's difficult to control homogeneity. It's difficult to deal with that throughout the process. The cutting of the fibers, we need to assess what's the best way to cut the fibers before using them and developing the composite. Superficial finish is an issue depending on the product. And in injection processes, in injection molding processes, because of the flow lines within the mold, sometimes the fibers, they take a certain direction and we don't have homogeneous properties, and that can be a challenge. I think it crashed. Okay, there you go. We have another one for the deck board production using wood, ground wood with very high concentrations of fiber, 60 to 70%. So if you work with composite development, it's difficult to incorporate such a high content of fillers in the polymeric matrix. This is a challenge in itself. So this material was used to produce the profiles. Challenges. 70% of wood, ground wood, or wood dust, the degradation of the fiber. We need to control the processing temperature because we don't want to see the fiber degraded. The size control, because in order to produce the profiles, we need to really control the size. We want to have the same product being produced throughout. And it's also difficult to maintain the same quality level for the end products. So we've developed, composites for filaments for 3D printing. In this case, we added sisal, wood, and lignin fibers in a polymeric matrix. We tried to incorporate as much filler as possible to obtain, filaments that can be truly used in manufacturing and in 3D printing. Well, challenges. Incorporating high amounts of fillers without changing the characteristic of the filament, because we need a filament with the same level of quality. We strictly control the size for 3D printing. That's the second challenge, right? The size control of the filament. So we need, uneven production throughout the process. Superficial finish that can interfere with the piece that is going to obtain later with the use of the filament, and the control of the conditions during the 3D printing. Depending on the polymer, we need to control the temperature during the 3D printing so that we obtain the proper pieces by using these composites. Here we have lignin composites, producing films using polyethylene and lignin to be used in the agribusiness. We do have some examples of the balloons that were formed by using the blow system. That's blow-based processing. Key challenges. The incorporation of lignin, because this requires the coupling agents, the aggregators, the control of the filler. Since we use the blowing system, we really need to control the lump formation. Lignin lump formation, because then the film cannot expand properly, and we need to be careful with the use of grates in the input. Blowing system, it's difficult to work with a blowing system because if there is any contamination or if there is any lump, this will hinder the process, especially in the blowing process. One of the key challenges is the smell of the lignin. Lignin has a specific smell, and that's a challenge for the industry in developing such composites.
Here's the last project that I brought to you, one of the most recently developed in Senai. geared towards the development of coffee capsules using residues from the coffee industry. It applied biodegradable polymers and the coffee husk that during the coffee benefiting this husk is blown, and then they collect this husk and it's incorporated in the biodegradable polymeric matrix, driving circular economy with the application of this husk. This project was awarded by FIEB with the Sustainability Award in 2023, and among the challenges we can mention uh, feeding this fiber has low density due to the processing the polymer of lower density tends to um, go down the container. The fiber stays on the surface, so we have a very efficient control of the content of fiber along the composite. We must have very specific cares with this feeding. We had also challenges related to the interaction between the matrix and the reinforcement. The idea was to produce biodegradable capsules, and the challenge was that this material was used in the food industry, would be used in the food industry. And the development of any polymeric material for this kind of application is already challenging. So we need to comply with all the standards for food grade products. So I brought projects, but a number of challenges. So as much as we have projects, the industry is demanding this kind of composites using natural fibers. This is an example of Mercedes. In this car, all of these parts that are around the car, they are produced using natural fibers composites, showing that the industry has been trying more and more to incorporate this kind of composite in their productive chain. And in the two images on the side, I brought two parts that were developed in Senai in partnership with Ford for the development of dashboards using composites made out of natural fibers. So we can already aid different brands with this kind of development. This chart talks about the market trend along the next 10 years. For 2024, the global market is estimated $383 million, and the trend is that up to 2024, this value will reach 794 million. So the market has been driven by the need for sustainable ecologic materials. What highlights this kind of composite made of natural fibers? So that's what I had to bring to you today. I thank you all for the attention, and I highlight that Senai has all the structure and is available if you wish to develop any project in partnership with us. Thank you very much. Do you have any questions?